Good afternoon, everyone. Let's kick off this afternoon with 3 other sessions. I hope you had all a good lunch. So our next session, let me just grab my pen. Our next session will be talking about taking models to the next level with Azure Machine Learning. So before we go deep into machine learning, let's do an overall recap of the applications and developments in machine learning, starting with a lot of development in e-commerce and computer vision, forecasting, predictive maintenance, autonomous agents like in reinforced learning and language. Each of these areas that have been transformed over the past few years by development and the machine learning landscape. Well, to really understand how much they've been transformed, if we were to go through each one of them, well, it would take the whole session time. So that's not really the plan for now. But what we're going to do is we're going to dig deep into one of my favorite ones, and that's a subtopic, language understanding. And we will deep dive into a couple of different scenarios and how they've been impacted by machine learning and deep learning. So keep in mind that everything we show here today for the companies that we are talking about and for the technologies we're using can be applied to any of those domains. So language understanding is one of the areas where we're seeing a lot of trends. Language understanding is an ambient computing on how we interact with our environment, whether there's through devices like the HoloLens or Microsoft Cortana. And then we have automation and scaling. So how do we reduce the amount of time that it takes to do a manual task? Whether that's a customer optimizing a customer support workflow or classifying medical or legal documents. In a way that reduces, of course, the amount of time a given human in the loop would have to spend. It's a very, very big industry. And we see in healthcare more AI is getting used. So, and the last one, and one of my personal favorites, is using text and natural language processing to get more data out of unstructured data, as we've seen in the first session. So, how can we interact with the world around us by using natural language, understanding language? So, we're going to tie all these different things together today with a company, well, you've already guessed so, with Tailwind Traders, a global retail company, and they want to expand their new retail markets and evaluating the clothing space. Well, initially they have no knowledge of machine learning, as we've talked before, or natural language processing. So they want to start from something simple and then build their expertise to create more advanced models. We will walk you along the path that Tailwind Traders will likely take when developing their text-based analytics service. Use our text analytics. Let's have a look of how it works. Okay, so if we go here to text analytics, I can go in, and if I have a specific review, like I loved the polka dot pants I bought in London, and I click analyze, then I get a lot of insights. Oh, I just made some writing mistakes. London. I click analyze. Then on the right side, we get a lot of insight that we can use that's now structured, that Twin Traders can use to enrich their application so they know specifically that we're talking about London. We can extract the phrases like polka dot pants, London store. So we can see that the person loved these things because we get a positive sentiment. So if I would say I hated the polka dots, we can see that now it became a negative sentiment, and we now can use this data in a structured way and incorporate it into our model. So why choose these APIs? Well, actually they work and it's easy. The APIs are easy to implement because of the simple REST calls. So being REST APIs, there's a common way to implement, and you can get started with all of them for free simply by going to one place, one website, and that's microsoft.com/cognitive. Since they're all stored together, it's an easy way to find all the different ones that are there and to also try them out, as we just did on text analytics. They're very flexible. Well, they have there's a breadth of intelligence and knowledge APIs, so developers will be able to find what intelligence features they need, and importantly, they all work on whatever language, framework, or platform developers are choosing. So devs can integrate into their apps for iOS, Android, Windows, and use their own tools that they know and love, such as Python or Node.js, etc. And if you think about if they're well tested, well, ever-growing collection of powerful AI algorithms developed by experts, developers can trust the quality and expertise being built into each of these services, because all of them have been tested enormously by Microsoft Research and are also used within the Microsoft tools like Bing, Azure Machine Learning, even in Word and PowerPoint. So now we're going to dig to the next step of how do we go from these cognitive services to building something a little bit more custom. Well, why would you think we need that? Well, we talked a lot about the cognitive services in the past few minutes and how good they are and how they enable you to get started with your business scenarios without even needing to write any single line of code. But however, what I've noticed is that there tends to be an 80-20 rule. Now, the pre-built AI services, whether it's in text, computer vision, or language understanding, usually will fill 80% of your business scenarios. However, you're going to find that there are 20% of your business needs that might not be filled by a pre-built model. And in those cases, you're going to need something more custom. What tends to be really interesting in my own personal experience, and as you're going to see, this applies to Tailwind traders as well, is that sometimes these 20% end up being the most valuable. In many cases, I want to start with the cognitive services because it really makes it easy to get started and then enable me to focus more deeply on the 20% of scenarios that I can't reach with the cognitive services. So let me give you a quick example in demo. I will just talk through it. If we go back to the previous example with the text analytics, and we would say in another example, like I had a wonderful trip to Seattle last week. I even visited the Space Needle 2 times. And then we get a positive sentiment of approximately 84%, which is quite nice. But now we make a writing mistake and we write wonderful with double L, our sentiment suddenly drops to 50%. So this specific example is not a crazy example because you know that something like that can happen. People will make writing mistakes. So depending on that, yeah, we could add first a spell checker before we're sending it. But it might change from use case to use case. You need to do maybe some other cleanup. So in that case, I want to build my own. So the way that I do this is I can use the Azure Machine Learning service. So what is the Azure Machine Learning service? Well, it's a set of cloud services and APIs with a Python SDK that enables you to prepare your data, build models, train models, and manage them, as well as the different experiments that you're using to build these models and finally deploy them at scale. So the Azure Machine Learning service are broken up to a few different artifacts. We have the models that we're going to build, the experiments of how we come up and develop them, the pipelines that allow us to take our experiments and build the pipelines for their deployment. And this is especially useful for linking our data to model development and redeployment. Then we have compute management, which allows us to manage compute at scale, creating clusters of virtual machines as needed. And image management allows us to manage different environments for our models and deployments, allowing us to deploy them on edge devices, on the cloud, or even just on-prem. And finally, we have our data storage, which is also integrated into one workspace. So, before we get started with any custom machine learning project, it's good to have a baseline. I think a baseline is very, very important, especially for a company like Tailwind Traders, because a baseline enables them to estimate the results before they just go and grab the state-of-the-art buzzword model and put it into production. With Azure Machine Learning services, with Azure AutoML services, it enables you to very quickly get started with building baseline models without even having to write a single line of AI code, and it works as this. So it works as follows. You provide data and the task that you want to accomplish and the constraints for that task. And what it will do is it will identify patterns from your data and it will try to apply them to many different models. They train these models in parallel and then will return to you what exactly is the best model baseline for you for that specific task, given the constraints that you gave. And then you can get started with that model in production and improve it based on what you already have. Okay, so let's have a look and build something like that together. Okay, so the first thing I need to do is I go in my machine learning workspace and I need to upload a data set. So I can go into my data sets and I've uploaded one already, and this is a set of this data set reviews, and I can see details around the data set. I can manage different versions of my data. I can manage who has access to my data across multiple different users. I can see samples of how the data is formatted, and I can even explore it. Dig into my data. So here I can see that I have a bunch of reviews, and each of the reviews got a rating. We can even view some statistics about the data, so we can see the distribution, that many of the reviews tend to be more positive than negative. But actually we'll soon see that are differentiated enough that we can build strong models, and then we can go from there and get started with automated machine learning. So all I have to do is AutoML, click create experiment, just give my experiment a name. I have to select the compute environment to run the experiment on. I select my data sets, and then I just choose the task that I would like to do. My excuses. Talking the whole day, it works on my voice. So in this case, we want to do classification because we want to classify each thing between 1 and 5. So which then convert and scale down into a positive or negative scale for sentiment. And we just select the target column, which in this case is the rating. And we have some advanced settings so we can choose what metric we want. So we will choose a metric called recall, and I can set all these thresholds. Do things like cross-validation, which helps ensure that our metrics is strong and validated across many different shuffles of our data set. And then I can even, if there are models that I think are going to be as valuable for my task. I can even block the algorithms, and then when I'm done, I just click start, and automatically now Azure will go and run multiple jobs and try to identify which models and which configurations will give me the best results. And actually I've already run this experiment on this data set for Tailwind Traders, And we can have a look at what this looks like. So I can see here a list of models, and I can each see of the different metrics and how they change for each models over the time. But the best performing model and samples of a couple different models, and I actually can go in and see some visualizations about the metrics and how well this model works so far. So we're going now looking in the visualizations, and we see how each model has been doing well, and we see some of them are doing very good. So what we've been building here now is a model that we can immediately publish also without writing any code. So now we also know what algorithms we can use and maybe fine-tune it if necessary for our next steps. So now that we have selected our baseline by making use of automated machine learning, and we think it's fine with what we have, let's discuss some of the more advanced Azure ML services. So they provide a foundation on top of which we can train any models, including some open source models, and then put them into production and manage. So we're going to be taking an open source model developed by Intel AI Labs as part of their NLP Architect library. And what it does, it provides us with something called aspect-based sentiment analysis. And before we were looking at our restaurant reviews, we got just a very simple sentiment average for each restaurant. However, for Tailwind traders, that doesn't really help to actually go in and fix any of the problems, because they still have one more step that they have to do. They have to send in an inspector who can actually quantify and see why sentiment is so good and at one branch versus the other. Aspect-based sentiment analysis allows us to address this challenge. What it does, it takes our text and it extracts what's called a lexicon from it, of both aspect-related and opinion-related words. And each of these aspects represent things we are interested in, like the price of food, cleanness of the place, and when we actually review, it would give us a sentiment for each one of these individual aspects, which then allows us to provide much more actionable resources from our model. These are the ABSA key messages. Producing knowledge regarding specific aspect hence enables to gain targeted business insights. Then we have unsupervised, does not require costly manual tagged data for training. And then we have domain adaptive, produces domain specific aspects and opinion terms. So in order to put this Intel model into production, we're going to use the Azure Machine Learning service. I think it's important to understand how the end-to-end process works, from taking a model from open source up to deploying it in production. And the first thing that we have to do is to prepare a data set. And then we have to choose our experiment environment. In this case, we're going to use a Jupyter notebook. We have to go and train this model and iterate a few of different versions. And once we do have a model that is ready for deployment, we need to work on putting the model into production. So what we're going to work on is all of this. So, and I just missed the slide. So in this session, we're going to focus on the experimentation phase. So I strongly recommend that you check out the next session that we're going to do, which talks about how you can take your model that you've developed and put them into production. So now it's purely on experimentation and registration. So for Tailwind traders, when they're thinking of how to take an open source state-of-the-art model and put it into production, they've noticed that they have a bunch of critical challenges. Things like being able to manage the environmental dependencies across the different packages and their different versions. Training a model with a globally distributed team and a globally distributed company is also very challenging. Managing very large data sets and compute, as well as scaling their compute. And in terms of compliance and making sure that they are ensured data protection, that only certain people have access to data and only the correct parts of the data. So when they build models, make sure that the models are interpretable in a way that they can understand how they were trained and how they can be reproduced. And the last really big challenge that they have is managing distributed training. So each of these things is somehow provided within the Azure Machine Learning service, but it would take a very long time to go through each and every single of them individually. So what we will do here is we're going to drill down into one of them and you will see the complexity of it. And then as we go and we solve and put this aspect-based sentiment analysis model for Tailwind traders in production. So we have these different steps that we go through: environment dependencies, cross-team collaboration, data and compute management, compliance and interpretability, and distributed training. So we're going to see how it's addressed each of these needs individually. So now let's dive into challenge of distributed training. When we deal with distributed training, we have to deal with a cluster of computers with all the dependencies and the environments for each of our nodes, computing scale, scheduling, distributing data across the different nodes, and so on. So you can imagine for any single company that can be very overwhelming. For distributed training, autoscaling is supported, as well as open source distributed training libraries such as Horovod, which has already become the de facto standard in distributed training. Now, when we're dealing with model optimization, we also have a challenge of distributed hyperparameter tuning. Now, what is hyperparameter tuning? Well, hyperparameters, typically when you see a new state-of-the-art model that's been open sourced, whether that's BERT or in this case our aspect-based sentiment analysis model, typically you will see that these models are trained on certain data. The performance of that model is depending on the distribution of the data that it's been trained on. And there are a set of parameters that are configured as part of the model that are optimized for the given data set, so that the researcher who is publishing the model can get the best possible performance. Now, when you take this model and you run them on your own data or train them from your own scenarios, you're going to have a different distribution of your data. So these hyperparameters might need to be adjusted. Otherwise, you will find a big gap in performance of your model when you apply it to your own data. So comparing to what's written in the leaderboard or in the papers. So this can be very challenging going through a manual hyperparameter tuning. And typically what we do is we take a data set and we come up with an algorithm and then we configure these parameters to build our first model. And then we change the parameters again and we build a second model and we try to see whether it's better than the first one and do this a couple of times until we max out the potential of these algorithms. And then we might change our model and then we have to do this process all over again. And you can imagine it's time consuming, tedious, repetitive, and really expensive process. It's all the steps that we need to do again and again and again. So Azure Machine Learning services help you manage this by running distributed versions of your model and allowing you to choose which are the primary metrics and you want to optimize based on the hyperparameters that you provide. And it provides a bunch of different policies such as bandit policies, medium stopping policies, and truncation policies that enable early termination. So if it sees that a certain set of hyperparameters isn't providing the best possible results, it will terminate those running jobs and release them and then run and prioritize the compute for models that are much more promising until you find the optimal set of parameters. So when I need to train an Azure machine learning model, it works as follows. There are just a few steps that we need to have to get started. The first thing that I need to do is to take the code that I have for model training and I need to send it to the Azure Machine Learning service. Then the service will then create the configuration for the experiment that I've just sent, and it will create a Docker image and it will deploy it to the compute target that I've configured, which will be linked to the data that I've uploaded in my data set. It will then launch a training script that I've configured and then in real time it will send me back the stream logs and metrics so that I can see how the process is going and if I were developing on my, just as I was going to be developing on my own computer. So to take this aspect-based sentiment analysis model into production, there would be 8 simple steps. First would be configure Azure Machine Learning workspace that we saw above. It would act like a central place for all our activities from storing data to training models. Then we need to define a compute target on which our training code is going to run. Then we need to upload our data. We need to create an experiment with the train code encompassing all the dependencies that we have and the training script. Then we need to have a training script that can be taken from the existing Endtoend code. Sometimes we need to adjust the train script from the original library for distributed training. In other cases, changes to the code would be very minimal. Then we will run an estimator to perform the training. And once we're done with the results of training, we get the models which we then need to register. So the best one we will register. And then to finish up, we can register our model so it can be deployed and tested and become ready for production. So let's have a look at the demo of how it can be done. So in the machine learning workspace, which is a really nice tool for development, we can manage our different computes and within our workspace. So I can create compute targets here and manage them. So I can also call something called virtual machine notebook virtual machines, and it allows me to make all kinds of virtual machines that I want, whether it's a standard virtual machine, as you might know, or something very cheap with low memory for development, or whether I want something more for custom development, like something with 56 gigabytes of memory, with powerful GPUs, with a lot of storage, and so on. So in this case, we already have a machine running, so I will just pull it up and for this environment. And then I have access to all the power of the Jupyter Notebook services. So for those who are not familiar with Jupyter Notebooks, the notebook service allows you to, in an easy way to build and develop data science experiments. And what we'll do here is to open the notebook for what we want to do, and we get started with Azure Machine Learning services. So the first thing that we said that we have to do is to initialize a workspace. So I'm going to create this workspace here, and you can create it from a config file, or you can provide your subscription ID, resource group, and workspace name from your Azure Machine Learning workspace environment. And all of this is contained in your workspace here. So we need to find a specific compute that we would like to set up. We also give our cluster a specific name. And then we need to set up our virtual machine size. So in this case, we are using the Intel P architecture, and that means it's more a CPU optimized for CPU model. So we need something that is more CPU optimized. So we don't need anything fancy in that case. So we can also take advantage of a virtual machine priority. So I'm going to use low priority compute, which provides an order of magnitude saying when I'm training, which makes things a lot more cost effective. And so I will be saving money, and I can use that cost to run more models or to run my models for longer times. So it gives me a lot stronger and better values for a fraction of the cost. And then I need to define how many nodes I want. So I set the number of nodes in my cluster as 1. So if I set it to 0 when it's done, it will completely shut down. So in this case, if I'm using the cluster a lot, and I like to use 1 so I don't have to continually respin it up, it will restart and recreate the cluster every time I want to run a job. And then I can choose the max amount of nodes, which enables me to configure and manage cost about how many nodes I want to autoscale to. So now we have our compute target. We can upload our data, so it can either be pull data locally from my dataset folder, or I can even download to that folder, and then I can upload this data. So it's very simple, and I just get the default data store, or I can define a custom data store where the documentation can be found here. So now we need to provide a training file. So the file actually trains the aspect-based sentiment analysis model, and so this model requires a couple of hyperparameters. So the first one is the aspect threshold, which tells us that we have these words that are aspects that we want to identify, and we have the opinion threshold, which these are the opinions that we want to use to tell us the sentiment about a given aspect that we're trying to find. So whether they're positive or negative, and the aspect threshold, essentially because this is an unsupervised model, tells us how many times we need to see a given word in a specific context before we decide whether it's an aspect we want to measure. And then the same thing with the opinion, how many times we need to see a positive or negative leaning word before we decide that it's worthwhile for the first experiment. But we're going to leave all of this on defaults. So then we have that, and now we can download all the dependencies that we need. So we use a spaCy parser for identifying the syntactic structure that links these aspects and opinion words to each other. And I used to love embeddings which will be used for identifying similar between those opinion words and the aspect words, so that I can identify which words are related to our aspects. And when we train this model once, we have that we can just initialize the train sentiment, we pass in our hyperparameters, and we just do and let it run. So even though this is an unsupervised model, we can actually benchmark the model by providing a very small set of labeled data that we can process, which is called an inner-outer method. And with the inner-outer method, I can essentially initialize the model that gets trained, and then I can load my test set as I can. So the run model on each of the sentences is in my dataset, and I compare it with the label data to generate the F1 score. And this can later be used to fine-tune the model. So once we have our training script now, we can actually run an experiment. So the first thing I need to do is to create an experiment and give it a name, which let's call it the ABSA, aspect-based sentiment analysis. We choose our workspace, and then we're going to run it. So here and again we need to give the parameters that we need. So our data folder, and then we run with the default values. And we just provide the data store that we created above. In the data folder, the main things that we need. And we need to provide the estimator with the source directory of where our transcript is located. And we need to give it the name of our training script. And we need to give it our compute target, of course. The environment variables we want, and essentially we can identify any of the pip or conda dependencies that we would like to add. Or we can define a specific even version of the dependencies if that's necessary. So once we create this experiment, we can just submit and then run the experiment. So after submitting and running it, so we're submitting it now. So I've already run it before, and then we see all the details that we get from the model. So it took about 3 hours and 37 minutes to run it, over 27,000 of samples. And if you take a look at it here, we can and look at all the different logs and informations that rented across the 27,000 different samples. So it's really nice because we use low priority compute. It's much cheaper. So running this model, if we were just to run it on a regular VM, and we can, based on our test set, that we have a very strong F1 score, and that we can configure any metrics we want, and that we can see that the extract and aspect size of our model is quite nice. So if we look to the results of these experiments in the workspace portal, what we will do right now is look at the metrics also here. So you can see I run fails and completes. So we have a couple of them that failed, hyperparameter features. So every time we submit a run, we have a snapshot of actually what has been done. We have all the details of it. So we can compare our work with other works. And for example, here 3 runs ago, it didn't work anymore, so I had to go back and everything is managed for me. I don't have to do any of that management myself, just as telling traders. So additionally, when a job fails, my excuses. So yeah, for example, runbook 43 that failed. We can take a look at it and we go to the output of the logs, and I can, wait for it, very quickly diagnose why the project failed and how to make that run better. But essentially I can see the logs. I can see that the model is training, and then during evaluation it seems that it failed because some I/O was not defined well. The doc2 I/O was not defined well. Well, that's very strange, so I was pretty sure that I had defined that. So let's go into the snapshot and let's look at what happened there. So when I go into my training file, we can see, oh, I actually called the wrong function here. So now I understand what went wrong, and I can use that to go back into my notebook to fix it and get a model that works. So that's very, very powerful. So now that we have a model, we go back to our notebook, we can actually optimize that model. So before we run this model, we just hard-coded our hyperparameters, but we can actually use the hyperdrive service like we discussed before. So we just set an early termination policy, the medium stopping policy, and for this that it should work. All we have to determine is our primary metric name, how many runs we want to run, and the number of concurrent runs, and we want to run on the same time depending on the size of our cluster. So what we can do is we can take a model that I've run, and what will happen here is you'll see that it will run multiple variations of the model with different features of all my hyperparameters, and then I can compare it. So I can even see across each of these hyperparameters how they affect performance. And so in addition to the ability to use the early stopping and a lot of the nice features, we have different kinds of optimization. I can also manually see and make manual configurations as well. And based on these very nice visualizations, and then once you're ready, I can take the best model that is there, and we can register it. So again, we need to give our model a specific name, and we give it a path to where to store the model, and then we can actually test and run this model. So to run the model, we're going to test it locally, and all I need to do is import it from Azure, and then I can use that model locally or remotely. So we set up also the workspace. So we run it. So now we want to run it on sample data. We have some couple of sentences that we have. So we see, I love the sweater, but hate it, and so on. So we got this negative sentiment here. So let's see what happens when we run it now. And here we see we get some part positive, and then we get a part negative. So now we actually have an actionable result. So we know that the sweater is positive, but the pants are negative. So I also see one like really great outfit. So see that outfit I enjoyed, but the shirt and so on. So we also the jacket that is positive, the cardigan that is then, this is a very positive sentence. So we can tell now our traders that maybe we need to stock more jackets because it's a very popular product. And maybe I should identify which sizes are more popular with the of these outfits. And maybe I should reduce the stock on these pants that people don't like. And now I have actionable outfits. Now, the last step that we need to do is to deploy our script. So what we will show here is how you quickly bundle this package and to get it ready for deployment. But in our next session, we will discuss more in depth how deployment can be done. So what we do here is we create a scoring file. The scoring file is some kind of interface that you build, and we need to just run that. So let me switch off my camera because this doesn't look nice anymore. So to wrap these things up, for this session at least. Okay. We've seen a lot in the last, almost hour. So we've gone through and reviewed the main industry advances in AI. We've introduced cognitive services. We've done it in other sessions already, where we want to observe the 80-20 rule. We have then went deeper and built a custom baseline model using AutoML without needing a single line of machine learning code. And we've trained a real-world open source aspect-based sentiment analysis state-of-the-art model with NLP Architect using distributed training and hyperparameter tuning. And we've actually put that model to work so that we can try it out, and hopefully in the next session you'll get to see more on how to deploy a model to production. So there's a few takeaways from this session that I want to summarize again. First of all, AI is instrumental to company success in the modern world, and most of the AI can be incorporated into production using cognitive services. However, for more complex tasks, Microsoft provides both simple codeless ways to train a model, baseline model, and very sophisticated Azure Machine Learning services that can simplify life of serious data scientists quite a bit, whether you are experienced machine learning professional or a traditional developer. Everything is covered. So let's have a quick break, and then we'll go deeper into how these machine learning models can be deployed.